In question 4, things are at least arranged with y equals in front, so that will make it much quicker to plot the lines. This one, minus 2x, that's a gradient of minus 2 and going through 0, 3. So going through that point, gradient of minus 2, so for every 1 across it goes 2 down. And let's just pick a point closer to the edge of the graph. I'm going to say when x is 4, so minus 8, 3 minus 8 is minus 5. 4 minus 5 is on that line, and then I can draw that line in, making sure it accurately goes through all the points. And that's the line y equals 3 minus 2x. I then need to plot these, so again making a table of values for x. I'm going to start with minus 1, minus 2, minus 1, 0, 1, 2. And y values I get from that are when x is 0, 3 zeros are 0, minus 2, y is minus 2. When x is 1, 3 minus 2 is 1. When x is 2, 3 times 4, 2 squared is 4, 3 times 4 is 12, minus 2 is 10. So we're going to see a significant rise on this one. These are going to be the same because we're squaring the x and there's no other x involved in the equation, so we get 1 and 10, and it's symmetrical again about the y-axis. So 0 minus 2 is there. 1, 1 is here, and I can see that that's a crossing point already. 2 across, 10 up. Minus 1, 1. And 2, 10. Minus 2, 10. So it would have crossed already, but we're not sure exactly what this root is here. So I can draw in the curve. And that is y equals 3x squared minus 2. I can see the two crossing points there and there. First one easy, x equals 1, y equals 1. And that's true for that. 3 minus 2 is 1 when x is 1. The next one, a little bit more difficult to read. It looks like minus 1.5 minus 5.5. That's pretty much halfway between there and there. So minus 1.5. Y equals minus 5.5. But of course we can check. If we're saying x is minus 1.5, 2 lots of minus 1.5 would be minus 3. So 3 minus minus 3, that's y equals 6. So in fact, that's possible from that graph as well. It's possible that I can read off the value y equals 6 at that point. So I'm going to say y equals 6. That minus there was totally wrong. That shouldn't have been there at all. Y equals 6. And I'm going to write that again clearly to make sure it's obvious what my answer is meant to be there. And now I'm going to solve that algebraically underneath. So we've got equation 2 and equation 1. And I'm going to sub 1 into 2, sub 2 into 1. Always going to substitute the linear equation into the quadratic. That gives me y, 3 minus 2x, equals 3x squared minus 2. So add 2x to both sides. 3 equals 3x squared plus 2x minus 2. And then minus 3 from both sides. 0 equals 3x squared plus 2x minus 5. Now I have to factorize, which is more complicated this time. But I know that that's got to be a 3x and an x because 3 is prime, so there's only one possible way that that can happen. And 5 is also prime, so I know that there's either a 1 here and a 5 there, or a 5 there and a 1 there. I've got to end up with 2, so in the middle I want 5x minus 3x. So I'm going to say 5x minus what's going to be 3x there. That factorizes that correctly, so I've now got x equals minus 5 over 3, or x equals 1. So this is not accurate. when I found that x is minus 1.5, that wasn't quite right. It was actually x is minus 5 over 3, or x equals 1. When x is that, y equals 2 lots of 5/3, that's 10/3, so plus 10/3 minus 5 over 3 times 2. 3 plus 10/3. 10/3 is the same as 3 1/3, so y equals 6 1/3 overall. 3 and 3 1/3. Or x equals 1 and y equals 1, as we've already seen. And these are my two pairs solutions here. And that's question 4 done.